All right, in this video here, we're going to talk about the point-slope form of an equation of a line, right? So linear equations have several different forms, and I'll make videos talking about each one of those different forms. The one for this video is what we're going to talk about is the point-slope form of a linear equation. So if we have a line passing through a point with coordinates x1, y1 with slope m, it has the equation y minus y1 equals m times parentheses x minus x1. Right? This is what we refer to as the point-slope form of a linear equation, and we call it the point-slope form because if we have a point, right, the coordinates of that point x1, y1, we put those numbers in here, and if we have the slope m, we put that number there. So if we know the point and we know the slope, we can just throw those numbers into the formula and we have the equation of the line. It's all right there. All right, so that's our point-slope form of the linear equation, and it's really important to remember this formula. It's another one that's important for you to know as you're doing algebra and precalculus and calculus. Is one of those formulas, one of those equations that's going to come up over and over again. One way to help you maybe remember what that formula is, this formula actually comes directly from the slope formula, which I just did a video about the slope formula. So if you haven't seen that yet, you can check that one out. But if you recall, the slope formula is m equals y2 minus y1 over x2 minus x1. All right, so that's my slope formula. Here's how the slope formula can turn into this point-slope form of a linear equation. If I take this entire denominator here, x2 minus x1, and I multiply both sides of the equation by that denominator. All right, so what I end up with then is, on this side, the x2 minus x1, that whole denominator cancels out, and I have that, the original thing I had there, m times x2 minus x1 equals my numerator over here, which is y2 minus y1, right? Which, that's this equation up here just kind of switched around, right? Here we have the y minus y1 on the left side. Over here, the y2 minus y1 is on the right side. And then, if I just erase the 2's on the x2 and the y2, well, then I have my point-slope equation, right? Y minus y1 equals m times parentheses x minus x1, right? This equation comes directly from the slope formula, right? Just take out the x2 and the y2, just make them an x and a y, and then just multiply that denominator to the other side, and you've got your point-slope form of the linear equation, right? So if you know the slope formula, m equals y2 minus y1 over x2 minus x1, there's no reason for you to ever forget the point-slope formula, because like I said, it's just multiplying that denominator to the other side, and you've got it. All right, so that's our point-slope formula. That's where it comes from. I'm going to pause the recording real quick and erase some of this stuff, and then put up a couple examples so we can work with the point-slope form of a linear equation. All right, so I put an example up here where we want to find the equation of the line through the point 1 comma negative 3 with slope negative 1/2. And then part B, we're going to then sketch the graph of that line. All right, so first part, I want to find the equation of a line. So I know a point, right, that 1, negative 3, that's my x1 and my y1, and I know the slope is negative 1/2, that's my m, and so I have all the ingredients I need to write the point-slope form of this linear equation, right? Remember, the point-slope form, which was up here a minute ago, but I just erased it, y minus y1 equals m times x minus x1, right? That's the point-slope form of a line. So all I have to do is take my x1 and y1, plug them in, take my m equals negative 1/2, put that in place, I've got the equation. All right, so it's going to be y minus my y1, which is negative 3, and since it's y minus negative 3, that minus negative is going to turn it into a plus 3, so it's going to be y plus 3 equals the slope, negative 1/2, times x minus my x1, which is 1. So there's an equation of that line that goes through the point 1, negative 3, and has a slope of negative 1/2, right? Again, I just take my x1, my y1, my m, and I plug them in to the appropriate place in that point-slope form. And just remember, if you have a negative value here, right, the formula has minuses there between the x and the x1, between the y and the y1. So if your x1 and your y1, if either one of those is negative, when you put it into the formula, that minus negative changes it into a plus. Right, which you can do that in 2 steps if you're more comfortable writing y minus negative 3 and then changing it to y plus 3. If you're comfortable enough seeing it and just writing it as y plus 3 like I just did, it saves you a little bit of time to do that. All right, so there's our equation of the line. Now what we want to do is sketch a graph of that line. All right, so sketching a graph, let me actually use a different color here. If we're going to sketch a graph of this line, it's not too hard to do. hardest part is actually drawing the x and y axis and doing all that stuff there. So if I want to draw the equation of this line, I'm actually not going to use the point slope form of the linear equation that we just found. I'm just going to go back to the information that they give us. This line goes through the point 1, negative 3. So let me go to the point 1, negative 3 and put a point there. All right, I know my line goes through that point. And then I know the slope is negative 1/2. Right, so if my slope is negative 1/2, remember the slope is the rise over the run. Right, so my rise is negative 1, which actually means it's going to go down 1 unit, and then my run is going to be 2 units over to the right. So from this point, it's going to go down 1 and then over 2. So it looks like I'm at the point 3, negative 4, and then it's going to go down 1 over 2 again, so I'm at the point 5, negative 5. And then it's going to do the same thing in the other direction. It's going to go up 1 and then left 2, and up 1 and then left 2, and then up 1 and then left 2. And if you counted your rise and run correctly, and if you labeled your graph well as far as how far you spaced out all your points there, all those points should lie on a straight line, and that line is the graph of the equation y plus 3 equals negative 1/2 times x minus 1. All right, so that's the graph of the equation. This equation here is the line that goes through the point 1, negative 3 with a slope negative 1/2. Right, so if you're given that information, you don't have to graph the actual equation itself. Just take the point as your starting point, 1, negative 3, and then just count the slope from there to get other points to put onto your line. Right, and remember, what the graph of this line represents is if I pick any point on the graph, right, if I pick that random point right there, and if I take the x and y coordinates of that point, when I plug those numbers in for x and y, one side of this equation is going to equal the other side, right? All of the x and y coordinates of every point along this line, those are the x and y numbers that will make this equation true. All right, that's what a graph of a line represents. It basically represents all the solutions to that equation. All right, so that's an example. When they give us the point and they give us the slope, it's really not that challenging to write the equation of the line in that point slope form. I'm going to pause the recording one more time and put up another example where we'll have to write an equation in point slope form, but they're not going to give us the same information to start with, so it's going to be a little bit more complicated. All right, so for this example that I just put up here, once again they're asking us to find the equation of a line, but this time they're asking us to find the equation of a line through 2 points. So all we're given is the coordinates of 2 points. Remember in the last example that we just did, they gave us the coordinates of 1 point and then also the slope of the line, so I can just plug those things into the point slope formula. Now that I have 2 points and I don't have the slope, well, in order to write the equation of the line, I need to know what the slope of the line is. So anytime you're given just 2 points and you need the equation of the line, the first thing you're going to have to do is find the slope of that line. All right, so this is going to be like a 2-step process here. The first step, finding the slope. M equals y2 minus y1 over x2 minus x1. All right, and once again, I'll label my points, x1, y1, I'll label this one x2, y2, and then I can put all those numbers into the slope formula and figure out what the slope of this line actually is, and then I'll use that slope to write the point slope form of this linear equation. All right, so my slope, y2 minus y1. My y2 is negative 4 minus my y1, which is 2, over my x2, which is 3, minus my x1, which is negative 1. All right, and I just did a video about slope and the slope formula, so if you're not familiar with what I'm doing here, you can check out that video where I go through an example of doing basically the same thing we're doing here. So now I need to simplify this, right? So negative 4 minus 2 is going to be negative 6, over 3 minus negative 1, that's 3 plus 1, which is 4, and then negative 6 over 4, I can simplify to negative 3 over 2. Right, because both of those have a common factor of 2. So if I cancel out those factors of 2, I get negative 3 over 2. All right, so that's going to be the slope of the line that we are dealing with here. So now that I know my slope, I can go and write the equation of this line in the point slope form. Y minus y1 equals m times x minus x1. All right, and it really doesn't matter which of these points I use for my x1 and y1. Any point on the line, if I plug in for x1 and y1, will give me a correct equation of the line. Since I already labeled this point x1, y1, I'm going to just plug those numbers in just to avoid any confusion. But if you plug in these numbers here for x1 and y1, you still have a correct answer. It looks different, but it's still correct. All right, so y minus y1, right? Y minus 2 equals slope, which we just calculated is negative 3/2, times x minus x1. x1 is a negative 1, so that minus negative 1 is going to make it x plus 1 in there. All right, so there's my equation of this line in point slope form. Y minus 2 equals negative 3/2 times x plus 1. All right, so that's how we can find the equation of a line. If they don't give us the slope, we got to figure out the slope, right? So we can use the slope formula. If we know the 2 points on the line, we can use the slope formula to get the slope. And then it's just like the example we did a few minutes ago where we just plug all the numbers in and we've got our equation. All right, so that is the point slope form of a linear equation. Now there are a couple other forms of a linear equation which I'm going to make some videos for as well. So if you're looking for slope intercept form or for the general form of a linear equation, check out those other videos that I'm going to be making actually in about a minute.